So when you're working on these, just be really careful with your signs in the formula and making sure you realize that a difference of cubes will have two sums in the a squared plus ab plus b squared part. And also, when you're working with a difference of squares, you're just square rooting the first term and the second term. That's all with those. The square of a sum we looked at a little bit in class on Wednesday, and this is what I was talking about, how you need to FOIL out whatever is in parentheses and that you cannot just distribute a power sign. So if we had 3x plus 4y all squared, that means you have to take 3x plus 4y times 3x plus 4y and actually either use the box method or FOIL that out. So 9x squared plus 12xy plus 12xy plus 16y squared. And that is going to be different than a difference of squares because we're actually FOILing something out in this instance. So don't get the two confused. Make sure you see the difference here. This is when you have a plus sign. There's not a conjugate involved in your factoring. And this is just FOILing something out. Sum of cubes is going to be very similar to the difference of cubes up here. The only thing that is different are that the signs change here and here. That's it. So in a cubed plus b cubed, then you have a plus b times a squared minus ab plus b squared. And an example of that is g cubed plus 64h cubed. And again, kind of go with the approach that I said previously. Take the cube root of g cubed and the cube root of 64h cubed, and that's going to be the a and the b. And then square the first term, multiply them together for the second term, and then square the last term. And that is your final answer. So again, square the first term, multiply them together, and then square the last term. And just be really careful with your signs. That is the only thing that is going to change.